We are going to review Venn diagrams and conditional probability and also look at contingency tables. For the warm-up, use the Venn diagram at the right and answer the following questions. Find the probability of A, which is that a student is in advanced algebra. If you take a look at the Venn diagram, you'll see that the information is already in decimals, which means percentages. So probability of A would be everything in the advanced algebra circle right here. And if we add those together, 0.2 plus 0.3 would be 0.5, or a 50% chance, or 50% of the students, I should say, are in advanced algebra. For part B, find the probability that a student is a junior or in advanced algebra. So this union symbol right here means or, and or means one, or the other, or both. So we're going to add all of these together. So we got 50% from the advanced algebra circle plus 0.25. So 75% of the students in the Venn diagram are a junior or an advanced algebra. C, suppose there are 160 people in the Venn diagram. Change each probability into a frequency number of students. And so we've talked about how if it's a decimal or percentage, you can multiply to figure out how many. So for example, just juniors, this right here. All right, so the 0.25, just juniors, we would do 25% of means times 160, and that would be 40 students, which would mean 40 students are not a junior and not in advanced algebra. We could do 0.2 times 160, and that's 32. And then for just an advanced algebra, not a junior, we would multiply 0.3 times 160, and that would give us 48 students. So frequency, you multiply the probability or the decimal times the total number of people. All right, review dependent events and independent events. So independent events, each event is not affected by any other events. So like each time you flip a coin, each coin flip, I'll say, each coin flip is an independent event. So we talked about gambler's fallacy, how one outcome does not affect the next outcome. You can get 10 heads in a row, but on the next flip, heads or tails is not more likely because of that. A dependent event is an event affected by previous events. An example, you got 2 green and 3 red marbles in a bag. What's the probability of drawing out a green marble and then a red marble? And so we can do a tree diagram for that to figure that out. So on the first flip right here, we can get 2 green or 3 red. And if we put the probabilities, there's 5 total marbles, so 2 green would be 2 out of 5, and 3 red would be 3 out of 5. All right, so there's the first one. But then the second draw, the probability changes. So let me draw in the green. So again, we can get a green, we can get a red, but they're dependent because if you take a marble out, then the probability changes. So again, I'll put just the probability of drawing these out right here. So we have, I'm going to change these probabilities to percentages. So 2/5 is 0.4. It'll be easier for me to write. And 3/5 is 0.6. Okay, so dependent probability, one depends on the other. So let's say you draw a green marble and then another green marble, so then you only have 1 left out of 4. I guess I didn't need to write those probabilities. But if you draw a green marble, and then a red marble, so there are 3 red marbles, but now out of 4. And here, if you draw a red marble first down here, and then a green marble, there's 2 green marbles out of 4. And then if you draw a red marble and another red marble, there's 2 left out of 4. So let's take a look at what they're asking. What's the probability of drawing out a green marble and then a red marble? So green marble and then a red marble. Okay, here it is. We're going to multiply our events. So again, you have a 2/5 chance of drawing that green marble. And if you take one marble out, then there's 4 marbles left, but then there's still 3 red marbles. So you can see right there we multiply the probabilities. And if we do that, we would get 6 out of 20. And you can reduce the fraction or change it to decimal or a percent, which I will do here. So I get my calculator working. Do I have a calculator here? Okay. All right, so we have 6 divided by 20. Okay, so it's a 30% chance of that happening. Okay, so that's an example of dependent events. One affects the outcome. Notice we had to change the denominator because there was 1 less marble. Let's do another example. What is the probability you draw 2 kings from a deck of cards with or without replacement? And again, we've done problems like this before, so it's a good review. You can make a tree diagram. I feel like it's easier to just do this. All right, two draws. So if it's independent, that's with replacement. So you're putting it back in the deck, so the next draw doesn't depend on the first. So there are 4 kings in a deck of 52 cards. And so each draw is the same because you put it back in the deck. And if you do that, you get 0.005917. If I change that to a decimal, a percent, move the decimal over twice, so you have a 0.5917% chance of drawing 2 kings in a row if you put them back in the deck. Now that changes if you keep the king out. So let's say you want to draw a king first, again 4 out of 52, but let's say you got a king, then there's 3 kings left out of 51 cards. So that'll change your probability slightly if it's dependent, so without replacement goes here, means you don't put it back in the deck. And our decimal is 0.004525, which translates to 0.4525%. So a little bit less chance of getting 2 kings in a row if you take one out. All right, conditional probability. So this is when something depends on something else. Here's an example. What's the probability that a student is in advanced algebra given that they are a junior? So we have this new symbol here for given. It's this line right here, given they are a junior. So probability that they're in advanced algebra given that they are a junior. All right, so when you get conditional probability like this, you look at the second thing. That's like the denominator of your fraction. Okay. So given that they're a junior, here's the junior circle. And so if we add those together, that would be 0.45 or 45%. So I'm going to put 0.45. All right, so that changes like the total that we look out of. We're just looking at juniors. What's the probability that they're in advanced algebra given that they're a junior? So let's look at the advanced algebra kids in that circle, 0.2. Okay, so here it is. Juniors in advanced algebra, you can divide that out. And if you do that, you get 0.44, or a 44% chance they're in advanced algebra given they're a junior. So again, the conditional probability gives you a new condition to look at. You change your denominator. Next example, you have polled your friends about chocolate and strawberry ice cream and have come up with the following results. What's the probability that they like strawberry ice cream given they like chocolate ice cream? So again, here's that given right here. All right, so look at your new denominator. We're just looking at the kids that like chocolate ice cream. Okay, so here's the chocolate circle. We add those together. So 35%, 70% are in the chocolate circle. What's the probability they like strawberry given that they like chocolate? So now just take a look at those that like strawberry ice cream in the chocolate circle. That's 0.35, and that would give you 50%. So half of those kids in the chocolate circle like strawberry. So that's called conditional probability, with that given right there. Here's that general equation. You don't have to memorize this. I feel like you just have to know what the formula or what the problem's asking you. So the general equation is the probability of B given A. Again, take a look at your denominator. It gives you the new bottom. You find the probability of everything in the A circle. And then you take a look. So if I draw this up. Okay, so this is circle A. This is circle B. So again, the A circle goes on the bottom. And then the probability of A given B, that part goes on the top. So if you look at our previous two examples, it kind of follows that trend. All right, conditional probability word problems. A die is tossed. So a number cube, dice, die. Find the probability that it's less than 5 given it is even. All right, so I'm going to draw all the different results of your number cube. So you can get a 1, you can get a 2, you can get a 3, you can get a 4, you can get a 5, you can get a 6. Okay, so what's the probability that it's less than 5 given it's even? So look at the bottom first, even numbers. Let's circle our even. 1, 2, 3. Okay, so there's 3 that are even. What's the probability that of those that are even, it's less than 5? All right, so we're looking at 2 out of the 3. It's less than 5 given it is even. So 66% chance. Or 67 if we round up. So about 67%. All right, how about the next one? Find the probability. Oh, a number is selected at random from this set, 1 through 8. Find the probability it is odd. Okay, so there are 1, 2, 3, 4, 5, 6. There's 8 numbers. I don't know why I counted. And the probability that's odd, 1, 2, 3, 4 of them are odd. So you would say 50% of them are odd. All right, how about this? Find the probability that are prime given they are odd. So now it changes the new total. So we know that we're just putting the odd numbers on bottom. So there's 4 that are odd. Find the probability that those are prime. So we're looking at the 1, the 3, the 5, and the 7. Oh, look, they're all prime. So 100% of those numbers are prime. Okay, we can look at conditional probability in something called a contingency table. So here's an example of a table, contingency table. Consider the following table giving the contestants in a dog race. Find the probability that a randomly selected dog is a basset hound. So the probability they are a basset hound. So this is out of the total. So basset hounds, there's 22 basset hounds out of the total 44. Which is 50%. All right, so there's the first one. All right, find the probability that a dog is a female. Okay, so females, here's total females out of total dogs. So probability that they are female is 20 out of 44, which is about 45.5%. All right, find the probability it is a basset hound given it is a female. Okay, so probability it is a basset hound given it's a female. So females we put on the bottom. So there are 20 female dogs. And out of those 20 female dogs, how many are basset hounds? So just look at the females now. Okay, so out of all the females, how many are basset hounds? And that is 12. So 12 out of 20, which is 60%. And the last one, find the probability it is a male dog. Here, let me change colors here. Probability it is a male dog given it is a boxer. So let's look at all the boxers. I have a lot of stuff here. Let's erase. Okay, so all the boxers. All right, so here's all the boxers. And out of those boxers, what's the probability it is male? 14 out of 22, so that's 63.6%. All right, so that's conditional probability. You have a given, which changes the total, and you have to think about what they're asking and write your probability. All right, so that's it. So you can practice.